Fabien Arignon from Sitia, who will also present a platform called Pumagri. That's right?
That's right, thank you very much. Je vais la faire en français, parce que j'avais pas prévu la faire en anglais, mais la prochaine fois, promis. J'ai la difficile tâche de passer en dernier, donc j'ai...
I have the difficult task of being the last speaker, therefore I don't have much time, I only have 10 minutes. But I'm going to be very concise anyway. My name is Fabien Arignon. I'm the director of Sitia. I thank the organizers for this invitation, and I'd like to tell you about our solution in agricultural robotics. Sitia is an industrial SME created in 1986. Since the beginning, it's been designing industrial machines and innovating systems. Our objectives are to applied innovation and to be leaders in the manufacturing of autonomous vehicles. Our strength is that we start from the needs of the ground. For our product, we met farmers to talk about the technical feasibility and the economic viability as well. We pulled all the necessary synergies to ensure the various functions of the machines. Our teams have developed a hard and soft architecture, binding together all the layers. Sitia also drafted all the protocols. Finally, our know-how in terms of safety enables us to have a really good performance. At technical level, in technological level, we design solutions that are adapted to the market. The agricultural world is very diversified, but at the same time very concrete. Our solution is designed and adapted to the farmers and by the farmers. Robotics seems to be the most adequate solution in the face of all the challenges at economic and society level. The farmer is at the heart of our solution. We develop our solutions for them and together with them to respond to the daily needs of the farmers. It is a robust solution and it is meaningful only if it is safe.
Excusez-moi, j'avais appuyé sur le mauvais bouton. Voilà. Donc notre robot est polyvalent.
So our robot is very versatile and can adapt to what goes on around it. It is interconnected to the web, to the present and future web solutions, but there is a lot to do to be coherent with our ecosystem. We are open to new solutions in France and abroad for new tools, for new applications. Come and connect yourself with us. What is most important is to be concrete. So this is where we stand in 2017. About 25 years of investments lead us to the validation of this demonstrator that you can see here on this video clip.
Comme expliqué précédemment, ce robot est
As I already explained, this robot is multitask and multi-crops. It is okay for vegetables, for arboriculture, and also to large field crops. We plan its intervention, it does the work with the objective of being robust and reliable. It is hybrid, autonomous in 24 hours in terms of energy, quiet, thanks to his original design. It can go from one type of crop to another. It can be adapted to any type of sensor, useful for new tools. It communicates with the tools. The most intelligent tools enable us to increase traceability. From the very start, this robot is safe. It is for all types of holding, and each function, each tooling is taken into account in the safety analysis and the analysis of its functions. It is connected, it can be programmed in the office and send real-time analysis. It can work with existing tools, but it can be adapted to future tools as well. The working speed is high thanks to innovating algorithms. Here we can see one of the possible functions, active mechanical weeding, whether on the row or between rows. Designed for the farmers and by the farmers, this robot integrates all economic data for a good return. Sitia has this industrial approach now to design, manufacture and sell this product exclusively for Fira. We are going to show you a video clip which we have just made public only 24 hours ago. This is the same robot in a vineyard which hadn't been tilled mechanically for the last 70 years. So we control the beginning of the row. We control the height of the tool over a few meters. And if it is validated, we launch the automatic action. There was supposed to be music there, but we don't have the sound, unfortunately. So it sounds a little sad. So the working rate is very high. You can see the speed is quite high.
Donc on tourne automatiquement.
So we turn around automatically, or in case of an obstacle at the beginning or at the end of a row, we can go manual and then the machine starts again the following row. So as I said before, the first time this robot came to this field, all the neighbors came to see what was happening, and the feedback, in fact, is extremely positive. So obviously, while the robot is working, the farmer can do something else. It's obvious. This is a result. And as I said before, this robot can work by night in vineyards. So that's it. So that was the robot working in a vineyard. So today we can bring to you industrial solutions for inter-row and intra-row weeding. We can do the mechanical maintenance of soils in viticulture. We work intensely with you to find new uses as quickly as possible. Everything you've just seen, that was up to 2017. Now, for the future, I take advantage of this opportunity to announce officially that with 1 year in advance, we are launching a pre-series manufacturing in 2018. We have partnerships with important players in vegetable growing and in viticulture. So if you're interested in a collaboration, please come and see us, because we look for partners to use our robots and to join our roadmap so that we can integrate your priorities, and I am at your disposal for any question you may have.
Fabien, merci.
Thank you, Fabien. You stuck to your 10 minutes. Great, thank you.
Just to take on the time you were able for you to ask, because we now have a question series, une session de questions-réponses. Alors, qui posera la première question?
So, who would like to start the first question? I have somebody over there with the mic, please.
Alors, si vous pouvez juste vous présenter.
If you could just please introduce yourself and then ask your question. We want to know who you are, and you have to stand up maybe. When I was in the audience, I couldn't see the persons who were asking the questions. André Gavalan, INRA, in charge of experimental farm, major farms in Osville. I have one question for Danibert, but I also have an observation to make, because we are talking about robotization. This is the extreme, but I think that it is a bit of a pity that the manufacturers, as we were saying this morning, or the industrialists shouldn't propose their own tractors with pre-equipped in the factory with all the controls for the guidance, except for the 200 horsepower engines. But then, of course, Kubota is an exception. Kubota should propose this self-guiding system. For the 1820, we're going to order one. What about the 600 horsepower robot tractor? When will it come to France, and at what price? Answer: yes, thank you. This is a very rich question. You know the range, because 1820 is not something everybody knows. This is a very small tractor, 18 horsepower for market gardening in particular. So no, this is not anticipated. We shouldn't be equipping with a GPS system. Now, concerning the automatic equipment of equipping of vehicles, this will be done according to the possible use of these vehicles, because it's difficult for a manufacturer. This is not the Kubota's vision, to equip systematically or to impose an equipment systematically onto a vehicle which will not necessarily need it as a main usage. So there we have a logic or a rationale with equipping or improving the horsepower range, but then afterwards we may add some equipment according to the horsepower. This is our own vision. We are recognized as a fairly simple equipment manufacturer. So our development in France, particularly for in the field, was based on this ability that we have to deliver tractors corresponding to the needs of the farmer who's purchasing it. We don't want to over-equip the vehicles. This is our own vision of the marketing aspect. Now, also, well, this is what I've shown you in Europe. It was presented in Europe, but on a stand in Well, what about the price? What about the price? Yes, this is exactly what I was understanding. So this is a phase where we are validating the pre-series in Japan. Now in Europe, it's difficult to answer this question because it'll take 8 years because we have a zone which is fairly white in terms of legislation for this type of vehicle. So we can see that it's not a simple problem. Of course, the tractor will be fairly easy to bring with the rationale with which we have developed it. It will be used with an operator, and it will be autonomous for a certain number of tasks. This is the idea. So not now. Any other questions?
Just in the front, en français ou en anglais, je ne sais pas.
Just in the front, in French or in English, if there's a mic. Could we have a question? Well, I have two questions to ask. First question to Mr. Juriens regarding your robot weed killing technique, because I think it's a very interesting technique. But what is worrying me is the fact that you are using it for a product. What about the mechanical aspect? Can you? Your system seems extremely elegant and very good. Well, thank you for the compliment. Well, you're right. The basic vision was to have a machine not using any plant killers, but our dreams are different from our reality for a startup. In order to satisfy investors, you have to sell things. So we decided to have a choice to launch ourselves on the market, and the spraying version was more easy to launch. But then in the longer term, we'll have mechanical tools, but we have the precision, and we have a platform, and we have the spraying system, and we thought that was too far away and too difficult to bring a mechanical tool. But of course, we are thinking about it. This is in the pipeline because you are using various weed killer products. You are differentiating between the mono and the dicotyledon. What about that? Well, could you introduce yourself first, Professor Emeritus at NSAT, higher agricultural education. Well, we are not using any products. Well, the farmer will use them according to its culture, our crop. So the dilution may be different. Well, and the machine is designed to be able to spray two products at the same time, one for the mono and the other one for the dicot. Answer. Well, yes, a second question to Mr. Séverine Bache regarding the use of its robot. Now, many vineyards are located in terrace areas, and to move from one land to another, how can this be done with a robot like that if it's all alone in the wild? Because if you have vineyards in terraces, in Banyuls area, for example, it's very difficult, and it's not going to be an easy task on site. Yes, it's fairly difficult, I agree with you, but the idea here is that today we have a robot. I was not able to play the video, but you can see it on our Facebook page or on the internet. We have robots that are doing all the lines and the rows, but then tomorrow we want to have machines which will be able to change from one plant of land to another in complying with the legislations and not going onto open roads. And the problematic is that of the terraces, which is even more complex because there we have to change plots, go from one plot to another. There are also land constraints that are very difficult to consider, and this is a real difficulty for an autonomous machine like ours. So we have a question to ask. Are we going to develop first robots that will be highly technological, which will be producing the most difficult part of the land, or are we working for the simpler 90% of the land? So this is the question to be we have to consider exactly what we want to do to address the right issue. And the terrace vineyards are extremely difficult for a robot, and I agree with you. Yes, there was a question at the back of the audience. I'm very sorry, I forgot about it. Yes, good afternoon, Nicolas Dühring. I'm heading a company in New Aquitaine. We are a distributor. We are also distributing nanotechnologies. And I have a question for Mr. Juriens relative to Ecorobotix. The first question, we can see we have plots of lands that are fairly flat. Now, with your technology, can we have more slopy land or more? That would be the first question. And then secondly, concerning technology and the detection of weeds, this is for major crops, but what about your technology? Can we work on market gardening or with various different types of crops? Because what is the weed detection technology, or what sort of answer? Well, relative to the question, well, this platform, as it is designed, is for flatlands or plots, but we can also work in slopes of about 5 to 10%. So, of course, this is not a mountain goat, of course. So we're working on a fairly flat land. Otherwise, the energy will be used up, and we'll have to change the batteries too often. Now, relative to the crops, we are already working with market gardenings in full fields, and we are working on beans, spinach, and for detection technology, we can recognize everything. It's not only recognizing one crop, we can recognize everything. So the robot is capable of looking at a map, and it will be able to recognize all these crops, and it will work accordingly. So in other words, we are able to detect corn or a beetroot? Answer, yes, it's a matter of classification, because we have a classification which is extremely precise about the crop the robot is working with. And then we have families of crops or weeds. We don't have to label them very precisely, because we know what we are working with. Yes, thank you. Are there any other questions in the room? I have one question at the front and a second question at the front. Let's move on. A third question over there. Okay, so we'll have to address these three questions. Yes, Jean-Michel Lebars, Ropagri, from Kuhn. So I have one.
Well, you will start to sell your robots in Denmark next year.
Sorry, can you repeat the question?
Yes, if I understood well, you will start to sell your robot next year on the Danish.
The first half of the series we will start to sell in May and June.
May and June. How you solve the regulation and safe to go on the market?
Yes, we believe we have. We have worked with safety in a research project in Denmark, and we have spent the last 2 years looking at safety, machine safety and functional safety in standards, and also relating them to the legislation in Europe. So we're not selling it as an autonomous robot that you can just leave and then go do something else. We are selling it as a surveyed robot, so you still have to look, or an operator has to make sure that the robot doesn't suddenly leave the field or something like that. The main reason for us has been that we can't find a geo-fencing system that can live up to performance level D according to the functional safety standards. So we can't ensure that the robot doesn't leave the field.
Is it okay for you? Okay.
Okay.
Here in the front, and then you. I have to manage, because can somebody give to this man a microphone, please?
Name's Larry Jacobs. We farm in California and in Mexico. Has anyone thought about this problem of terraces and robots leaving fields? What about putting sensors or transmitters around the fields and key points to talk to the robot and say, just don't go beyond this point, or here you need to turn. And wouldn't that help solve that problem?
Your question is addressed to somebody in particular?
They can all take it.
Who want to take it? Claes, go on.
We discussed this option a lot because it's very easy and it's very similar to a lot of the mowing robots that you see for small gardens. The problem is the cost and the work the farmer has to do if he has to put a big cable around every field where he wants to use the robot. Or he has to put a lot of sensors in each corner of the field. If he has 50 fields, that's a substantial cost and can be a time-consuming assignment just to get the robots there. And then suddenly the robots aren't as attractive. So in my opinion, we have to find a solution where we don't make a physical fence like that.
It's okay. Monsieur?
Yes, just a question for Claude. I'm an organic farmer. I wonder if you've tried organic herbicides, maybe a high acid vinegar or something like that. And what will the cost be when it comes out?
Yes, we have made also some tests. There are some organic products coming onto the market. By the way, we are not supplying or manufacturing any products by ourselves, but we have some of our customers made tests with Beluga from Belgium, which is kind of pelargonic vinegar. So it's working. So our robot is just a mean to put the product right on place, and then it is up to the people who are supplying the product to find new organic product. But yes, there are product arriving, and Beluga is working also with our robot. And regarding the price, you mean the price of the robot or the Beluga? The price of the robot in Europe. It will depend on the type of algorithm and how many algorithms you want, but the end user price will be from 25,000 euro to 28, depending on the amount of algorithms. So easy to buy. You want one? Yeah.
Just behind you, I've got a question, yeah.
Florent Banquetel, conseiller viticole à la Chambre d'agriculture de Loire-Atlantique.
Viticultural councillor. I'd like. I would have a question for Yanne Courcoux, because she's been working in this particular field, and your robot is very interesting. Are you using? How is the animal perceiving your robot answer? Well, you're right, because we are working with a laboratory from the University of Rennes and CNRS. This is what we call the animal ethology, so the interaction between the robot and the animal, or the hen and the poultry and the small lights. These were the luminous light stimulation to limit the habit. So the idea here is that the poultry would listen the arrival of the robot. They would identify it so that they would go to the side and make sure that when there's this sound they should move, and in order to avoid contact with the robot. So, but we know that this is totally different according to the species and also according to the one genetic stem to another. And so you need a robot which would be able to adapt according to the type of animals or the type of crops. And one of our difficulties for us is that if you have a hen or a turkey, they will not react in the same manner, and genetically they will also be different. So you are working on various sounds, because from what I have heard, you can clap your hands, or you can shout, or you can do plenty of things like that. While we are working on various frequencies or intensities of sounds, or the colors and stimulation, because the animals will not react in the same way if it's blue or red or yellow. So we have to work on all these various stimulations. Yes, behind you there's another question over there, and there will be another number of other questions. You can see there's somebody else who would like to ask a question here. Well, in about a year's time, it will be open. It will be the Higher Education of Electronics of the West, which will be operating, and for 15 months following the engineer's degree, we will be training some students to the needs of digital agriculture. So my question is that your presentations are extremely interesting, but of course you have been talking a lot about the tool and its implementation. And this is very interesting, but my question is, are you also working on the design of added value services, which would be provided by the use of more massive use of these new tools? Now, who would like to answer this question? Well, yes, yes, you're right. Now the work is huge because what is important today, and this is what we saw this morning, this is the issue of agriculture, because we're talking about energy efficiency, we're talking a lot about the size. What about a small or a huge robot? There are various issues here. So it'll be the same. What we need is to be able to use the current sensors, and those that will be used tomorrow, because we don't know the sensors which will be used in 4 or 5 years' time. Still, we should be ready through the data fusion and a bit of artificial intelligence. We should be able to bring the added value of this data, and first we have to capture it and implement it in a repeated manner, and in a very precise manner. And then we will be able to imagine plenty of things after that. But this is the first step. Does that answer your question? Yes, it does, actually. But of course, there would be other answers among the members of the panel. I'd like to make another comment here, because today we are at the very start of the data in the agricultural world, and it's being developed with Arignon. There are plenty of startups like that now. But what is interesting is that so far we've been using data at the local level. In other words, we have had a sensor operating on a drone, and then it's relayed onto a processor or onto a tractor for spraying products, but then we are at the local level always. Now, I think that tomorrow there will be a global level which will be implemented. So you will have a number of machines operating at the same time. There will be intelligent, smart machines through sensors that will be collecting data throughout the world and will be able to study large size data, and this will be artificial intelligence which will take over. And I think there will be plenty of data analysis to conduct, but I think that this global vision will enable us to see things that we cannot see at the local level. It's difficult to anticipate what it will correspond to, but I'm sure we'll see the propagation of a number of diseases, and we'll have so much data that we'll be able to study and survey the propagation of these diseases and the real factors of development of these diseases. So I think we'll be able to adapt the products as a result of that accordingly, and thus we'll be reducing the weed killer products thus. Now, there was another question in the audience as well. There are two questions over there. You have the mic, sir. Yes, one question. I don't know whether it's Mrs. Courcoux or Courcoux. Courcoux, yes. And yourself, André Gavalin, INRA, for crop experiments. And now we have a major issue because we have spring crops, we have pigeons, attacks. So I was thinking about your robot sending sound to frighten the birds, for example. Because I think that it doesn't seem to impact so much the ground, but we could imagine that if this robot can also circulate and outside the plot, it will frighten the birds maybe. What do you think of this particular idea? Answer. Well, my robot doesn't frighten too much, because this is not the aim, because that would really frighten all the hens and they would no longer lay eggs. So I'm not sure I can do that. So there's a limit to what you can do. But still, yes, there are birds frightening techniques, and there's a company or a laboratory we are working with, which has been working with an aeronautical industry company, because they were interested in this particular objective. So things have been done in this field, and there's a company not far from here, actually, which is very much specialized in that type of operation. And we could imagine that this robot is operating well, and it hasn't got a great impact, but it could also work on that type of job. It could also fulfill this.
The last question.
My question is building on a comment of Mr. Jæger. In the end, adoption will be driven by a farmer or a farm operator deciding whether the total cost of ownership of the new solution is going to be positive for him or not. Now, total cost of ownership is largely driven, I think, by reliability and availability. So without exception, all the robots are stacked up with components that are quite complicated, sensors, all kinds of new computers, which are sourced from supply chains which are not originally the agriculture supply chain. So can any of the speakers maybe comment a little bit on reliability and availability of the future systems you are offering to this new market?
Claes, you want to begin? Because at the beginning the question was for you, so...
One of the things we looked at a lot is that the components has an IP class of IP67 at least. So it's protected against water and dust. But a lot of the industrial grade products can't be used outdoors, and that is a problem. But it's possible to find components that can, but they're also often more expensive. But I think the main reliability of the components are actually pretty good, even though there's a lot of components and it's very complex. I think the main concern we have is actually the wires or the cables, because of vibration, that they are getting worn in the installation. So that's actually the main concern we have with our robot.
And if it breaks down, is the operator the right person to repair such complicated systems?
That very much depends on what it is that breaks down. If it's a simple thing, a connector that falls out or something like that, then yes, he can maintain it. But if it's something more advanced than that, then no, the operator can't fix it himself. But if you look at combine harvesters or tractors today, then an operator can fix it himself anyway. So it's not a lot different from a modern tractor.